Hey guys, it's day 16 of college algebra. Today we have a really short assignment, only about 7 problems. That's because it's a fairly difficult one. It's one in which we're going to be talking about how to factor fractional powers from an expression. Now, for all the problems we have today, these will likely be greatest common factor problems because they're simply not ones that you can typically do using things like the AC method or the crosswise techniques. And so we're going to actually do 2 example problems, and I'm actually going to do 2 of the homework problems as well if I have time, because these can be difficult and can really express some of the weaknesses people have when it comes to factoring. Let's start with something really simple, only dealing with positive powers. And it's important to note that in these problems, note the rules we're going to follow are very specific. If you don't understand the rules, it can be hard to determine what I'm going to factor. And if you can't determine what you're going to factor, it's even harder to determine how you're going to factor it. So let's take a look at each one of these and showcase how to factor with the fractional expression. Here we go. Okay, first of all, the rules. Rule number 1, big rule number 1. In general, this only works if you're factoring with fractional powers in the same denominator. What it means is, if there's fractional powers that are different parentheses, this really doesn't work well at all. Secondly, in general, when you're looking at these problems, you're always going to try to factor the lowest, I can't spell lowest, happy Monday, lowest power as a general rule is always when you're going to factor. Factor the lowest power when possible. Let's take a look at a simple example that illustrates both these rules. So I have 2x to the 1/4 power plus 5x to the 3/4 power. Now you notice here in this example that we have just x's, which is beautiful, raised to these fractional powers. We have a power of 1/4 and a power of 3/4. Now, what I'm going to do, this first of all showcases our first rule. These need to have the same parentheses if possible. This is a power on an x. This is also a power on an x. We're going to see ones in a second that are powers of parentheses functions, and so this needs to stay the case. They need to be the same thing here and the same thing here. They'll have different powers, but in general, the bottom, the other piece of these powers needs to be the same. Now, what we're going to choose, we need to choose to always factor the lowest power. Now, in this case, the lowest power is the 1/4. So what I'm going to factor out is x to the 1/4 power. Now, when I do this, I can also factor out any numbers that they have in common. So like if this was a 2 and a 4, I could factor a 2 out. But since there's no number in common, this is my greatest common factor. So my lowest power is always what I'm going to choose as my greatest common factor. Now, when I take that 1/4 power out, the 2 will actually be left alone because we're taking an x to the 1/4 power out. That's usually the easier of the 2. The harder of the 2 is what happens to the 5. If I take a 1/4 power out, remember the important thing to note is if I have something, let's say this is old news, if I have x squared plus 4x to the 4th plus 6x to the 5th, and I want to factor an x squared out, it's important to note that I can take the whole thing out, or I can take pieces. And when I take the pieces, I end up subtracting in order to get this to work. Okay? How do I get this 3? I subtract 2, and the 2 comes from right here. How do I get this 2? I subtract 2. 4 minus 2 gives us the 2, 5 minus 2 gives us the 3. And so when you factor, factoring becomes subtraction. always true. When you factor, you end up subtracting the fractional power that you're taking out. So if I want to take a 2 out, I had to subtract 2 from every one of these powers. And even in this first one, that makes sense, because if I subtract 2 from it, I would end up with x to the 0 power. And x to the 0 power is, of course, 1. And so this helps to illustrate what's going to happen here. This becomes x to the 1/2 power. The reason why it becomes x to the 1/2 power is because you're taking the 3/4 and you are subtracting 1/4. So we take the power that we had that we're trying to take out and we subtract it from the powers of each of these. If I subtract it from this one, I end up with x to 0, which becomes just 2. If I take it from this one, I get x to 3/4 minus 1/4 becomes x to 2/4, which simplifies to 1/2. And so this tells us how we can actually factor out a fractional power following the same rules. We just have to recognize how those rules really, truly work. We're going to always make sure when we factor, you have to have the same parentheses. Secondly, when we factor, we're going to factor the lowest power. Whether that power is a smallest because of the number in it, whether it's a positive or negative, doesn't matter. We just factor the lowest one. And then when we factor, we're going to end up subtracting that factored power. Let's take a look at this same problem done with something in place of x. So 2, parentheses, 3x plus 1 to the 1/4 power plus 5, 3x plus 1 to the 3/4 power. These two are the same basic problem, and how we're going to do them is going to involve some of the same basic steps. Take a look. The first thing I'm going to do is we want to make sure that they do in fact have the same thing in the parentheses. This is make sure we're following rule number 1, okay? Next, rule number 2. We need to factor the lowest power possible. Well, that in that case, the lowest power is this 1/4 power. So we're going to take that power out. Now when we take that power out, we have to take x to 3x plus 1 to the 1/4 power. We're going to take that thing out. Just like how we took x to the 1/4 out, but we take everything with the 4th out. So the 3x plus 1 will also come out. Here, this will become 2. 3x plus 1 to the 0 power. Because remember, we're subtracting. We take the 1/4 minus the 1/4. We get the 0 power there. We take the 3/4 minus the 1/4 to get the 1/2. The only difference between these two is that there's going to be some simplification that goes on with this one that you wouldn't have probably had to do in that one. So, in this case, the 3x plus 1 to the 1/4. This power of 0 makes this become a 2. And in this one, it would become 5 times 3x plus 1 to the 1/2 power. These two are the same basic problem. Just instead of dealing with just x's, we're dealing with a function. Oh, excuse me, I'm sorry. So there we have it. This is the process we're going to go through for all of our problems today. We're going to verify that they do in fact have the same parentheses. We're then going to take out the lower of the two powers. So I take out the 1/4. I do not take out the 3/4 because it's the higher of the two. So always take out the lowest of the two. And then my big one that's going to be the struggle for many of us today is going to be this piece, where we actually simplify it in a way that makes sense. Let's take a look at our first real example. That's like tonight's homework. So this is very similar to what we're going to be doing here. We're going to make sure we follow all of our rules as we do so. And my function is, I have 3x times x plus 2 to negative 1/3 power. Ooh, negative 1/3 power, that's not good. Plus 4 times x plus 2 to 2/3 power. This is my first example. Okay, let's make sure we go through our steps. Step 1, we want to make sure these are the same. This is the same, this is the same, so the first thing is done. We got to make sure these match, otherwise we can't do this. Now, step 2, I want to take the lowest power as my greatest common factor. So I can see here, I have a power of negative 1/3 and a power of 2/3. Notice I'm ignoring the 4 and the 3x because they're not really important. They're not what I can factor, right? There's nothing I can remove from both 3x and from 4. So I can't take a greatest common factor of those two. I can only take a greatest common factor from these two. So I choose the lowest one. The lowest factor in this case is the negative 1/3. Remember, negatives are always lower than positives. Always. This is always the case. So if there's a negative power, that's probably what you're going to take out. Okay, from here, let's talk about how to do that. Okay, so I'm going to take out the x plus 2 is a negative 1/3 power. Now, the question becomes, what's left behind? I'm going to show all of my work for this one, but usually you're going to skip this middle step. There's nothing I can take out of 3x, which says 3x. I take the x plus 2. Now here's the thing. If I take negative 1/3 and subtract negative 1/3, because remember, I'm supposed to always subtract the factored power. So I'm factoring a negative 1/3. So I take the current negative 1/3 and I subtract the factored negative 1/3. The double negative is going to make that a positive, and I'm going to turn this into a 0. Over here, so I have plus 4. This would become x plus 2. Now, I currently have a 2/3 power. I'm going to subtract away the negative 1/3. And here's the thing. 2/3 double negative becomes plus 2/3 plus 1/3. This would become a power of 3/3, which is a power of 1. So this is right here. This is the big step. This is the first step we've got to recognize as being what will show our work. The behind the scenes stuff is you have to make sure they match, they do, and you have to decide what you're going to factor out. But when we factor out, we're here. Look how we did it. The negative 1/3 subtracts away to become a 0 power. The negative 1/3 subtracts away to become a power of 1. Notice that this 2/3 was a power of 1 because of what we're doing. We're subtracting that factored power. Subtracting negative 1/3 means to add 1/3 to it. 2/3 plus 1/3 is 1. Now, once you get some practice on this, the typical thing is to go ahead and jump right here. To kind of skip this middle step, because you're so smart and so good. Anything to a 0 power becomes a 1. And 3x times 1 is just 3x. Over here, anything to the first power is just itself, so this becomes 4 times x plus 2. Now, the next big thing you can do, we can actually distribute and simplify. Okay, so we're going to take this 4, we're going to distribute it to the x and to the 2. That wasn't possible before because the 4 was attached to something with a power other than 1. When the power is 1, remember, it disappears. Before, it was a power of 2/3. We can't distribute until we get rid of that 2/3 power. Well, we did by factoring. And we happen to factor by that negative 1/3, which causes that 2/3 to become a 1, allowing us to take this step. From here, we still have this outside piece doesn't ever change when you're doing these problems. What can change is the inside piece. This becomes 3x plus 4x plus 8. And then, of course, we can simplify in these brackets to become our last step, which is x plus 2, negative 1/3 power, 7x plus 8. Notice how wildly different this is than the original equation. Very, very different. But that's why you have to take the time to factor these correctly. Again, let's go through our steps. Step 1, we have to make sure these match. They did. And now we decide for part 2, we need to have the greatest common factor be the lowest. Remember, negative is always lower. So we take that negative 1/3, and we take our first step is to bring that out. Once we bring it out, we have to pick how the rest of it's going to fix. So the 3x stays a 3x. The negative 1/3 causes this to become a power of 0, which will eventually be replaced by 1. Over here, the 4 stays. And as 2/3, remember, you're subtracting the power we're taking out. The power we're taking out is the negative 1/3. 2/3 minus 1/3 becomes plus. 2/3 plus 1/3 becomes 1, and powers of 1 disappear, giving us line 2. We then distribute for line 3 and simplify to get to our end result. This is the constant flow of these kinds of problems. Let's look at our next example. So this will always be how we approach these problems. Example number 2. You'll find that all these examples look pretty similar, and these all look a lot like your homework, which is really important. Next example, 2, parentheses, 5a minus 1 to the 3/4 power, sorry, plus 7a times 5a minus 1 to negative 1/4 power. Okay. So, step 1, do they match? Yes. The first thing we gotta make sure is, do they match? They do. That's a good sign. Next, we gotta decide, what are we gonna take out? Well, my powers in this case are 3/4 and negative 1/4. I have to always choose the lower of the two, so I'm gonna choose the negative 1/4 to be the one I take out. So, I take 5a minus 1 to the negative 1/4 and bring it out. Remember, the power that is lowest always comes out. So negative 1/4 power comes out along with its parentheses. Negative 1/4, negative 1/4, the 5a minus 1, the 5a minus 1. Now, what happens to these pieces? The 2 is going to stay. The 7a is going to stay. What's going to happen is this is going to affect the powers. So I can actually fill in all of this, and then all I have to do now is fill in what's going to happen to the powers. Well, I take the 3/4 minus the power I'm taking away, which is negative 1/4. Double negative, 3/4 would end up becoming plus, and 3/4 plus 1/4 is a power of 1. Over here, I have negative 1/4 minus this power I'm taking out, which is negative 1/4. Double negative would make that plus. Negative 1/4 plus positive 1/4 would become a power of 0. You'll notice this theme becomes common. Notice it's in a different order. Before, the first one was the 0, the second one was the 1. Now this one's the 1 is first, the 0 second. That's why it's important to recognize which one you're taking out and how that's going to fit together. Okay, we have a power of 1, power of 0. Let's simplify those. From now on, this front piece is going to stay consistent because we've already factored it out. Then now the question becomes, how does the second part simplify? So again, the 2 stays a 2. The 7a stays a 7a. A power of 1 is just the parentheses. A power of 0, remember, powers of 0 become a 1, and 7a times 1 is just 7a. Meaning we're now here. Now we distribute the 2, and then combine like terms. So again, the 5a minus 1, that factor term never moves, never changes. 2 times our 5a and times our negative 1 would become 10a minus 2 plus 7a. And now we end up with 5a minus 1, negative 1/4 power. We have 10a and 7a for a total of 17 a's minus 2. I cannot put these two together because this one still has a power, but this one has no powers left, so that's as simplified as it gets. Now, again, notice how these all follow the same basic rules. They're not easy rules, but they follow the same rules every time. You take the lowest power and bring it out. So negative 1/3 is the lower of the two powers I started with, so I break it out. Negative 1/4 is the lower of the two powers I started with, so I bring it out, along with its parentheses. Then the rest becomes, how do I simplify the inside? I take that 3/4 minus 1/4 to get the 1. I take the negative 1/4 minus negative 1/4 to get the 0. Up here, I took the negative 1/3, subtracted it from the negative 1/3 to get a power of 0. I took the 2/3, subtracted negative 1/3, give me a power of 1. And then I just have to distribute and simplify. As I did say, I would promise to do a few homework problems. I will. You have 7 problems in total tonight. I'm doing 2 of them with you. So let's see how we do. Okay. So your first homework problem is number 44. Let's do it together. If you have your homework ready, you can go ahead and follow along with me. I have 4x, parentheses, x minus 1, to the negative 2/3 power, plus 3, times x minus 1, to the positive 1/3 power. Okay, let's take the powers out. So this is the part that's always predictable. I'm going to make sure to take out the piece that has the lowest power first. I spot that piece, lowest power, these two match, so I know we're doing good. Let's take that piece out. So I take x minus 1 and the negative 2/3 out, and then watch what stays behind. 4x and the 3. But watch what happens to the powers, okay? Negative 2/3 minus, so this is my original power, this is negative 2/3, this is the power I'm taking out. Negative 2/3 minus negative 2/3 becomes a power of 0. Okay? Positive 1/3, which comes from here, minus the power I'm taking out, which is negative 2/3. Double negative makes that positive. Negative, or positive 1/3 plus 2/3 would give a power of 1. You notice how that trend is pretty constant. One of the powers becomes a 0, one of the powers becomes a 1. When they simplify, you'll know you did this correctly if that happens, because that's good. Okay, now, powers of 0 become a 1. So, I have x minus 1, negative 2/3 power. That part stays the same. What's going to change is what's inside. Okay, so this becomes a 4x, and 4x times 1 is just 4x plus 3, and then x minus 1 is to the first power, which means it's just x minus 1. So this is, it's really common to go from here to here if you're really good. It's because you'll see how to take it out and simplify it as you go. Writing this step is good, it just takes more time. Now here, again, the x minus 1 to the negative 2/3 power. Okay, we take 4x, it's still 4x. This 3 can be distributed because there's no power left. So this becomes plus 3x minus 3. And now I can simplify what's inside that parentheses. Again, the first piece, the factored piece, stays pretty much the same the whole time. This becomes 7x minus 3. I simplified everything that I physically can, meaning this must be our solution. Again, note how we did the process. We find the lower of the two first. This is the lower of the two. We took that out. And the rest becomes, how do I simplify via the power rules, and then simplify via the order of operations rules. And there it is. Leaving that there. Let's look at 46. We've done plenty of these where we factor out the negative power, but you remember, you're just always factoring the lower one. It's always the lower of the two, not always the negative, because maybe there isn't a negative, and so it doesn't change anything. Let's look at 46. We have 3t times 10t plus 3 to the 1/3 power, plus 7, 10t plus 3 to the 4/3 power. Okay. I immediately look at this list and be like, okay, there's a 1/3 power and a 4/3 power. The 1/3 power is the lower of the two. That's the one I'm going to take out. 10t plus 3 to the 1/3 power. What's left behind? We have 3t times 10t plus 3. We subtract the powers. So 1/3 minus 1/3 is a power of 0. Plus 7. 10t plus 3. 4/3 minus 1/3 is 3/3, which is the power of 1. Notice I'm going through this time and doing it as I'm doing the work. I simplify as we go. Okay? The 10t plus 3 stays on the outside to the 1/3 power. That's not going to change. Now, powers of 0 become a 1. Powers of 1 disappear. So this becomes 3t times 1, which is 3t, plus 7, parentheses, 10t plus 3. Now I can simplify algebraically. 10t plus 3 to the 1/3 power. Distribute to 7, so this becomes 3t plus 70t plus 21. Shoot to 7 to the 10t becomes 70t. 7 to the 3 becomes a 21. And then we combine like terms. Notice that again, the factored piece just kind of sits on the outside. 73t plus 21. And here's my solution. Note the process one more time. And I cannot stress these kind of mini rules enough, because they're going to be where you're going to have the most problems. Okay? First, you want to always make sure the parentheses match. For every homework problem tonight, they will. So 3 or 10t plus 3, 10t plus 3, that part's good. The outer pieces won't match, but that's fine. They're not supposed to. Next, you have to decide what's the lowest power. For this one, it was the positive 1/3 was the lower of the two. This one, the negative 2/3 was the lower of the two. Here, the negative 1/3 was the lower of the two. Always choose the lower of the two, and remember, when it comes to these, negatives are always lower than positives. This is going to become your greatest common factor. It's what's going to come out and stay out the whole time, right? The negative 2/3 power comes out and stays out the whole time. The negative 1/3 power comes out and stays out the whole time. Okay? And then finally, last step, we're going to use the factor out of the factored power, and it becomes subtraction. So if I factor out the 1/3, I have to subtract 1/3 from both of these. 1/3 minus 1/3 becomes a 0. 4/3 minus 1/3 becomes a 1, which algebraically simplifies. Notice that powers of 0 and 1, so something to the 0 power becomes a 1, and then something to the first power just stays the same. So if I have, 2x plus 4 as an example here, if there's anything to the 0 power, it becomes a 1. So that's why this piece becomes 3t times 1, which is 3t. Anything to the first power just becomes parentheses, 7 times 10t plus 3. And then you have to make sure to distribute and simplify. Distribute and simplify is always going to be your last major steps. Always. So, step 1, make sure you're in the parentheses is the same. Step 2, find your greatest common factor by using the lowest power. Remember, negatives are always lower than positives. Step 3, factor that piece out using subtraction. So, subtract 1/3, subtract 1/3. Simplify using the powers of 0 and the power of 1 rules. And then, last step is to distribute and simplify. There's only 7 problems tonight. I've already done 2 of them, number 44 and number 46. They follow the same basic rules every time. The trick is going to be making sure you understand how to follow those factoring rules well and simplify correctly once you have done those factoring rules. Best of luck, you guys. I look forward to seeing what you guys are working with. Remember these rules and how they fit together, and I'll see you guys next time.